Hey everyone, I want to thank you for tuning in to one of EPARTRADE's Race Industry Now Tech webinars. If you're a part of the racing industry or you're just passionate about racing tech, don't forget to like this video and subscribe to our channel so you never miss a new episode.
Good morning and welcome to Race Industry Now, the weekly webinar series from EPARTRADE, presented to you by ARP, Performance Plus Global Logistic, Feria Racing Component, PIC, Fifth Third Bank Motorsport, Quire, and C-Tech Manufacturing. I am Francisque Savignan, the founder and CEO of EPARTRADE, the racing industry, every minute, every day. This is episode 557, and we're going to be talking with Brian LeBarron from Vibratech and Fluidampr. With me this morning are Julie Kin, the co-founder of EPARTRADE and wonderful host, and the voiceover of our new video, Mr. Brad Gillie. Julie?
Good job, Brad. But thank you, everyone, for joining us today. We're excited to have Brian back on with Fluidampr and Vibratech. And how I see their product line, they are like a rotating insurance policy for racing and beyond. Brad?
I like the way you described that as a rotating insurance policy. I think that is well said. And thank you for the kind words. Judy, Francis, we'll see y'all coming up here in just a bit. But we have a lot of fun things to talk about here on this week's webinar, and we're very excited about it. The topic is Torsional Vibration Solutions for Modern Powertrains. And Brian LeBarron, Market Development, is joining us now. Brian, welcome back. How you doing?
Hey, doing great. Thank you for having me on, Brad. Francisque and Judy, great to see you again. Yeah, I got a great presentation lined up today to talk about torsional vibration solutions for modern powertrains and really take a look at what Fluidampr and Vibratech are both fully capable of today.
Yeah, let's just start out and look, Fluidampr is a trusted name, an industry leader, one that we're all aware of. But who is Fluidampr? Just give us a little bit of a background.
Great. Yeah, I'm going to share my screen and we'll go on a little bit of a history here because you often hear the name Fluidampr, but also Vibratech TVD. So bear with me here. I'll get the share screen going.
There we go. We can see that you're sharing your screen. There we go. We can see what's on your screen now.
Pop that up there. Okay.
Perfect.
Little chicken and the egg, a little history lesson here. So Vibratech came first. The lineage goes back to 1919, but we're going to fast forward to 46, and that's when the viscous damper was invented in the US by Vibratech TVD. From there, it took off in OEM side heavy duty, over-the-road trucks. If you think about history then, interstate commerce is taken off, the highway system's going in, the damper was needed in trucking. And it stayed that way for, well, right up into the late 70s, early 80s, when the guys are really hammering hard with the V8s in racing. And the race engine builders then, they went to Vibratech TVD and said, hey, can you make us a damper that holds up? And so they said, yeah, we downsize it and make it work for motorsports. So from about 85 on, Fluidampr became known in the industry for viscous dampers and as an aftermarket catalog item. Did great, and we caught the eye over time of some OEMs. That was around 2015. So Fluidampr was being approached by OEM high performance in automotive and marine and defense, and I was there. I've been with the company for almost 15 years now, and it's like, whoa, we're catching the attention of some really big names. They like to use Fluidampr. Can we scale up for production? So the silos came down between Vibratech and Fluidampr, and we said, yeah, sure, of course we can build it in scale. And moving from that day forward, we can OEM supply automotive high performance in volume at OEM quality levels to OEM powertrain warranty standards. So it blew the doors wide open, especially in the last 10 years. All together, between Vibratech and Fluidampr, we can do torsional vibration analysis, damper development, volume production, manufacturing right here in the United States, and fulfillment, just-in-time inventory. We're headquartered about manufacturing, engineering, everything's headquartered about a half an hour south of Buffalo, New York. So that's where we're at today, Brad.
I like that. I do want to let our audience know, and if you're a frequent visitor of our Race Industry Week webinars, that anytime you have a question, please feel free to type it into the chat. And we absolutely want to be able to talk about the things that you're curious about and answer any questions that you might have about Fluidampr and the products and the things we're going to be talking about here today, including new product development. So, let's just talk about torsional vibration dynamics and what changes we've seen in recent years.
Sure, absolutely. Back up a little bit, what is torsional vibration? And it's the end-to-end twisting of a rotating shaft. And it can happen in a number of spots on the powertrain. So I'm gonna pop this shared screen back up again.
All right. There we go.
There we go. Let's fast forward a little bit here. So you'll have it on the crankshaft. That's what we most commonly think of. But you can also have that end-to-end twisting of a shaft. Think about a camshaft, especially when you get long ones, V12s, inline sixes on agriculture equipment, drivelines, and even electric drive motors. So this is what really plays in the dynamics between Fluidampr and Vibratech is like, we can pull in the Vibratech experience from OE heavy duty and gas compression and agriculture and marine and transit and apply what's already being done in other parts of the engine, downsize it, make it work for motorsports. So again, with these dampers, we can make them from as light as 1 pound up to 7,000 pounds, 100 horse to 25,000 horse. Now think about that, 25,000 horse, that's twice as much as a top fuel dragster, but that happens every day to get natural gas delivered to customers across the country. Quite a dynamic that we work with. So what's really changing? Is fast forward here a little bit. You have engines are getting smaller. The power density per cylinder is going up. The temperatures are going up. We're trying to pack more power in a smaller displacement. So you get a lot of torsional vibration spikes, a lot more twisting and spikes of that. And we want to stretch that RPM range out. So now we're 8, 9, 10,000. I don't know, the guys in late model dirt track, they're pushing 11. So that power band is getting really wide. All that translates to heat. Heat's got to go somewhere, but we'd like to cram more and more stuff inside that engine bay. So the heat doesn't have anywhere to go. There's not enough airflow around it. And then we want to make everything to last. And again, when we're thinking in the mindset of motorsports, maybe to the end of the race, OEM production that we're working with, at least 5 years, 60,000 miles. I mean, so it's playing both dynamics. You can have 1,000 horsepower car off the showroom floor, but it's got to last through the warranty period. So we're balancing a couple of things. Again, engines getting smaller, lighter, forced induction, more power per cylinder. That's all generating this heat. Damping's got to take care of that into consideration too, and the durability requirements of it.
Mm-hmm.
So we can do this a couple of different ways with newer designs. And over the past 5 to 10 years, Vibratech and Fluidampr pioneered some new internals to the damper. So it's probably good to show what we're traditionally known with is this, the outer housing, an internal inertial ring, and this tiny, get it up to the camera here, you can barely see it in the camera. There's a shear gap in there. It's about the width of 2 human hairs, about between 5 thousandths and 10 thousandths of an inch. That little gap is where the silicone goes, and it's pressure injected in there. So you can see it's not much. It's mostly inertial weight. That silicone acts as a spring, and it's what the shearing of the inertial ring in there as a vibration twist is counters to it, takes that vibration, transforms it to heat. So that's how a traditional Fluidampr works.
Okay.
Now, I mentioned got to spread that RPM range out. got to have different masses, different inertial weights. So we can actually have a nested design. We can put two weights in here with a bearing between them, have them resonate at different frequencies across the RPM range. So that broadens out your range to take care of all the, not only the harshest vibration, but any also secondary, tertiary vibrations that line up. So this is really ideal for, you know, newer engines, wide power band, trying to get a lot of power out of it, and it's going to hold up. So
that's pretty impressive. I like that.
So that's one new design. Or say we got to get rid of heat too. So the second design that has been developed in the past, like say 5 to 10 years, we can take the chamber, split it in half, put cooling fins on both sides, so we can double the cooling surface area and dissipate that heat. Now this work really good for high horsepower engines. We're talking like 250 horse per liter. And it's good for off-road applications or marine or any place where you have really low airflow and you got to dissipate that heat. You notice on some of the modern hypercars and such, they're getting air ducts down into that engine bay to dissipate data as well. So a nested design, a dual mode design. What's cool about this one with the split chambers, you can run different density materials inside of there, different silicone grades. You can really fine tune this thing. It has a lot of flexibility. But sometimes things get really crazy, and air cooling is not going to solve it. So we worked with one OEM. It was 1,000 horsepower, 11,000 RPM V12. The damper became an internal engine component because the amount of damping and the amount of heat it was generating, it needed to sustain, it needed to keep that silicone from overheating. So we actually put it internal to the engine and shot oil jets down onto it. And that outer housing is an oil, is a jacketed. So when the oil hits that, sloshes around, cools it down, pulls that heat out, and goes to the oiling system on it. What was interesting about this, not only, 1,000 horsepower, 11,000 RPM, it also ran dual overhead cams with a cam damper on each one. So again, a great use, clean slate design, where we're working with the engineers at the design level to get the damper the size that they need, where it needs, too cooled, plus cam dampers.
That's really cool.
Last, we talk about durability. And where else can you get better durability than to go endurance racing? And if you were walking the pits of an IMSA race 5-6 years ago, and you kind of walk by that Pratt Miller booth and Corvette Racing, you would have seen the C8R engine, and on that was a prototype fluid damper. So at the time, we're working at the OE level, working on endurance, we're making sure that everything holds up. We actually developed a patented housing. We call it a twist lock. Again, the patent was awarded 5 years ago. This is well tested. This is, I want to say, old news in the OE side world. But what was cool with a twist lock, we could take the damper off after the race, unlock it, open it up, and do silicone sampling on it. Now, what we found was not only was the silicone and the damping and the damper holding up for a 24-hour race, it was lasting the season. That's the importance of thermodynamics and heat dissipation when it comes to viscous dampers. Once we achieve that, the durability is unbelievable. There's not another product on the market that can match the durability of a viscous damper when it comes to dampening the torsional vibrations.
That's really impressive to have something like that go a whole season.
So hats off to the engineers. Like I say, we've been working with viscous dampers, really traced the lineage back to 46. A lot of knowledge in-house, a lot of things documented that we can just build on. And then the diversity across all the industries, we can pull from heavy duty, we can pull from marine and defense and automotive, and just make products that work.
Yeah, I like that as well. And I know, especially for our audience here in the United States, the fact that it's made in the USA and you guys have been around for so long is a big deal. We have a quick question from the chat that says, talking about modern cars in your previous slides, how do you integrate your dampers with hybrid powertrains?
Each one, each one is a case by case, so we're working with the OEM and the designers on motorsports. We can actually go in and do what we call torsional vibration testing. So we have the test equipment we can bring in and take measurements and see where we're at. And a lot of it comes down to finding what our frequency is, and then looking at how much envelope space, how much space do we have to work with to get a damper integrated into that. And I think a good case example of this is we've been working with, on the Vibratech side, with transit bus manufacturers that are running diesel to a hybrid electric powertrain. And we're getting a lot of backlash between the electric drive and the drive shaft because it's going to a differential. And really, it was finding when that electric motor kicked in, is that spike, getting that drive shaft to twist up, and was sending a resonance up through the cabin. You get a lot of NVH, a lot of just noise like the riders didn't want to hear. So it really came down to doing the testing, doing the analysis, and then designing it to spec, and then coming up with a flange to adapt that into it. So that worked in that case. And it works similar to other EV powertrains. If it's a drive motor or if you're working with a drive shaft, it really involves just doing the consultation and getting engineers involved. And we have all the test equipment to take it to you.
Yeah, and that's incredible, and what a great question too, because my limited experience, I just got a new 4Runner, which has what they call the performance hybrid, and maybe it starts off on the electric engine for the first couple, miles per hour, then the engine kicks in, and you might get on the gas, and all of a sudden you see the turbo light up, and you see the electrical light. I mean, there's a lot of different things going on at one time with an engine like that.
Correct.
Yeah, that is really incredible. So how are viscous dampers different than conventional rubber style dampers? You talk about the silicone and things like that. What can you tell us there?
Yeah. So on the conventional rubber side, we call it an elastomer damper. It's basically a hub. It has a bonded elastomer and the inertial rings on the outside of it. And what we find is they're designed for a narrow range for stock specs where the engineers feel it's going to be the worst, to a given power level. So stock, everyday grocery getter, commuter, fine. It's when you start doing power adders to it and you start overworking it. And again, you have dealing with heat. Damping creates heat. The heat breaks down the rubber, and you'll start noticing that rubber elastomer will crack and bulge and pile out. And worst case scenario, this is really important for motorsports, is if that slips and that inertial ring slings off the hub through your radiator down the track. We've seen really bad instances on the drag strip and on circle track. So it's really important that you're inspecting that rubber elastomer for safety standard. So the difference then going to a viscous type damper, again, I'll maybe point that up here and so you can get a closer look here. Everything's encapsulated inside the housing. There's nowhere for that inertial ring to go. And then just that tiny shear gap is in there. That silicone acts as a damping medium, almost like a spring.
Mm-hmm. Another question from the chat, Brian, it says, what is the lightest SBC damper that you produce?
So the short answer is, you're around 8 pounds on the small block damper. But the long answer to that is you need weight, and it's a trade-off. Heavier damper will give you more ability, more inertia to stop that twisting, stop that vibration. And by doing so, you're going to prolong bearings, you're going to make the engine run more efficiently, just everything's going to live happier. You lighten that up, you don't have the countermass to combat that twisting action. So the second part to that is we can get really strategic now with the mass. And I'm going to use our new Coyote damper as an example for this. We can make the damper out of a lot of different materials. And in fact, I'm going to share the screen again because I got some slides about this to show what we can do with this. Because not only can we do different internals to it, we can make it out of different materials. So I'm going to dive a little bit into this question about weight and design. And it's important not only the amount of weight, but where it's located and how it's centralized. We want that weight in the inertial ring. So bear with me, I'll show the screen again.
Yeah, no problem. This is fantastic, really sharing the technology and everything, and what a difference maker it is, just because of how important a piece of equipment this is as well. We're not just talking about smoothing things out, we're talking about engine life and, what not being able to effectively reduce vibration can do to bearings and, different internals.
All right, a couple examples here. All right, so when we're dealing with weight, we can make that outer housing out of now steel, aluminum, or aluminum with a steel hub. Now, our new 5.0 Coyote damper is aluminum with a steel hub, and that's the lightest damper that we make. So that you're taking all that weight from steel to aluminum, but the effective weight is in the inertia ring inside the damper. That's where we want it. A lot of the new OEM high performance dampers, they're aluminum housings as well. Now that internal inertia ring, we can make that out of different density materials too. We can do steel, cast iron, bronze, aluminum, or a hybrid combination of two with that nested design. What's interesting, we talk about cam dampers. That's a little 5-inch damper, but it runs a bronze inertia ring because we need that weight density to achieve the damping that we need. So different material sciences will give you different damping effects. Weight's important. We all keep an eye on that. You need a certain amount to dampen it, but we don't want to give up performance either. So a lot at our arsenal how we can design this. Same goes, I guess, also with the silicone. On average, inside of it, about 45,000 times thicker than dirty weight motor oil. It's really, if you open and spill it on the table, you're taking a putty knife and Scotch Brite to clean it up. But different silicone comes in different viscosity grades, and we can really fine tune that one way or the other. That's why, a lot of that's proprietary, but the options are there for sure.
So when it comes to the silicone, is there ever any concern for that wearing out?
Here's the trick to it. The silicone will hold its damping tolerances from -40 to 300 degrees. It loves that temperature range. It's wider, it's more effective than oil or other type of liquid type material, damping mediums. We wanted to keep it under 300 degrees. Above that, it does start to break down. That's why the heat dissipation and monitoring the thermodynamics of it is so important. If we achieve it under 300 degrees, as we just saw an example with IMSA, I mean, the sky's the limit on this as far as durability. And in motorsports types applications.
So how do we do that? Is that, is that the technology that you already have built into it, or, what do I need to know depending on the application that I might be thinking of?
Yeah, put it on in motorsports, put it on the engine, run it. It's going to last the life of the engine. You don't have to, the other thing is going to wear out long before the damper does.
I like that. Another question, is the steel hub heat treated?
That, yes. And when you're looking at the dampers with the steel hubs, if you have a specific year, make, model, and there's questions on that, feel free to call our tech support if you have any questions on materials or need prints or anything. I'll just give the number there. It's 716-592-1000, or you can reach out through the website through live chat. It's fluidampr.com. Okay,
that's great. All right, so when should an engine designer start to consider including torsional viscous dampers?
Early. So if you have a clean slate design or you're building production race engines, the sooner that you can bring the engineering team start thinking about torsional vibration and NVH and durability, the sooner that you can bring in our staff to collaborate, the better. Again, I'm going to defer back to the shared screen and some slides because I want to show you a little peek behind the curtain on engineering. All right. First, we are OEM engineering software compatible. So our computers will speak to your computers. We can swap files. Everybody's on the same platform. So that advances things, really speeds up time to market because there's no lagging in data translations or anything. Second, we can do the CAD and finite design tools. We can work compatibly with most production race shops with OEs. Again, getting everybody in that common platform really speeds things up and gets the engineers really collaborating well. The next step, we got proprietary vibration modeling software. Again, with viscous dampers, it goes back to 46. We got decades and decades of resource material to pull from. What's also really cool is like we were talking about spacing and fitments and how do you measure that when maybe we're in Buffalo, but race engine builder, maybe they're in Detroit or LA or wherever. It used to take a long time to build prototypes and ship them around and cut ships. But now with 3D printing, we can print the models within a day usually and print them, make sure the pulley alignment's going to work, bolt patterns line up, everything's good fit and finish, and we can ship a 3D printed plastic model and bolt right up and make sure everything's going to work from a fitment point of view. And then we can make different various prototypes for testing. We can, again, travel to their facility. We can do it on engine, off engine, in vehicle. All equipment is mobile. So we can bring, prototypes, ABC versions, and do a couple of different runs before or afters and see how it compares and really dial in what's prototype is going to work and take it into production. So when it does go to production, again, we're located south of Buffalo, New York. The facility is about 100,000 square foot. We have 128 full-time employees, and it's fully advanced manufacturing. What you see to the left of us is one of our high-speed EMAG machines, where we have basically 3 automated stations, put the stock in, and it just brings it through with CMM inspections along the way. And we can do that in low to high volume. I want to stress that we hear that oftentimes, well, I didn't know if Fluidampr could make it in, this type of OEM scales. Yes, we can, because we're pulling in Vibratech's assembly and processes as well too. Again, behind where the production floor is a warehouse. We can handle the inventory for them, on time deliveries. And we have OEM awards, a few behind me here, that vouch, yes, we can do this in scale, to precision, in value. And not only that, back it with quality assurance. We can do FAI inspect or quality for defense and aerospace levels. We can do PPAP for automotive. The picture on the right is pretty cool. You'll see that data matrix on there. So we can do lot traceability. We know, all the statistics that go through that assembly process. It's all cataloged and stored, and we can look back and see it if the OE or the engine builder chooses in their process. Again, multiple CMM inspections along the way, and everything is all certified to ISO standards. So that's the advantage of Vibratech sitting behind Fluidampr. You say, you may have heard Fluidampr as a catalog item. This is what we truly can do behind the scenes at the OE spec level.
Again, that's impressive. And I love, I don't know what the right word is, maybe not accountability or something else, the trackability of being able to, like you said, have everything logged and cataloged and everything.
Yeah, and it's great. And that all comes down through, of course, meetings and processes. That's why it's really important when you say, when do you start? Well, start as early as you can, because you can bring all this into the design phase, into the testing phase. The modeling software can speak to one another. It really is a great partnership when you start early. One last note I just want to put in there, because it is really important. We see this globally with OE suppliers, is we have corporate social responsibility management, where we also tracking not only everything from a part production quality point of view, but also anything environmental, human rights, ethics, and sustainability. And that's all can be managed and reported on as well too. I know that's really big when it comes to OE accounts.
Mm-hmm. That is a big deal. One thing, and I want to get back to something we talked about earlier, and I'm not sure, if we properly covered it or not, but the why and where are torsional vibration dampers used in the powertrain? I know we talk about the vibration damper. You also mentioned camshafts and different things like that. Could you expand on that? What else can you tell us?
Sure, sure. So again, I think just to reiterate that when we talk about torsional vibration, it's the end-to-end twisting of a shaft by a torque input. Now, most of us think about crankshaft when it comes to torsional vibration, because you got each cylinder's firing, it's putting a torque pulse down on each, and it's twisting and flexing as it's going around, thousands and thousands of times per second. So the crankshaft damper is an obvious choice. You can smooth that out, the crankshaft from vibrating. It's going to save on your bearings. It's going to give you better timing. Just less wear and tear overall. On the driveline end of it, we often see this as an NVH issue. You get your drive shaft off-centered. I'm not an expert in drive shafts, but you get it off-aligned, and that is going to give you that rotational imbalance. And that's what most of us think about is the rotational imbalance. But again, you get that twisting going on too. And then sometimes that will set off, that vibration sets up, and something else, like I mentioned, the bus, you get a floor panel that's at the same frequency that they resonate, and the two will just play off of each other and give you that rumbling noise, or that noise that you don't want. So the driveline dampers become more of like an NVH concern. We're just now starting to hear and really looking at the EV motorsport side of it. It's like, what's failing? Where is the torsional points when that electric motor kicks in full torque right off the bat? What's wearing, what's breaking down? Can a damper fit in there? Can we really make these electric drive motors, robust and durable? And how can we work with tier 1 suppliers in that to add our damping technology or knowledge into the future of EV? And motorsports, we know, is the testing ground to it. And then the last one I want to touch on again too are the camshaft dampers, because they've been in play for a long time in industrial engines, particularly agriculture, big inline diesel engines, where you not only have a crankshaft damper, but also a camshaft damper to settle down the valve train noise, to give you better valve timing, but also less chatter, more, again, going back to the NVH, like we don't want to hear things rattling and going on and such. But that camshaft damper can, again, downsize. As I mentioned earlier, that one we make on that V12 is only 5 inches, but we're using different material inside of it. We love collaborating and partnering up with other engine builders and pioneers in motorsports. Hey, can we get a camshaft damper on a V8? I'm sure it could be needed in again, circle track or any type of late model type applications.
That's really fascinating. Another question from the chat, and if you're viewing with us live right now, if you do have a question, please feel free to type it in, because we definitely want to answer the things that you want to know about. This one says, can you talk about vibration analysis between naturally aspirated and forced induction engines?
Good question. So again, we're looking at torsional vibration analysis if you're running naturally aspirated or if you're running boost. And really, we're looking at, it all comes back to cylinder pressure and how much torque is being applied. So if you're boosting your torque through boost, adding forced induction, and you increase that torque that the crankshaft is seeing, that amplitude spike is going to increase. I guess a great example of this, if you're building up a car and you have the stock OEM rubber damper that we described, and you go from naturally aspirated to boost, you say you're going to add another 125, 150 horse, you're going to see it. And that crank is going to twist end to end more, amplitude's going to go up, and you're going to start overworking the OEM damper. So again, if you build it up in stages, look at that damper, you're under the hood, shine a light up in there, looking for cracked, bulging, or missing rubber on that. And if it starts accelerating, you start seeing that, you're overworking the stock damper. It's time to upgrade. Again, swap out to a viscous damper. You don't have to worry about it.
Yeah, I'm glad we're talking about this, because again, depending on what people are doing, and I know people are designing things from the ground up, and I'm going to get the best parts and things of that. We have a lot of people out there in the racing community, depending on what you're doing. You're taking something and you're improving it, you're adding power to it. It's real easy to overlook a damper and say, well, it's got one. Right. Which is a big mistake for a lot of people, especially depending on the way you're adding and how much power you're adding.
Correct, correct. And again, the more power you add, the more you're going to overwork it. And again, what we hate to see is the OE failures where it does slip and come off that rubber bonding. Gosh, we've seen so much damage through the radiator, out through the bottom of the car, down the raceway. The funniest story I've heard, and this is really scary, again, circle track racing, or inertia ring slips out, went right through an outhouse in the infield. Luckily, they say no one was in it at the time, but that's a lot of weight slinging off the end of a motor at high RPM. That's something to be really mindful of.
Wow. I mean, I laugh at that because it's a funny story because no one got hurt, but it's a huge example of, again, just the reason why you get in touch with someone like Fluidampr and say, okay, let's make sure we do this right, because doing it right starts from the internals to the externals and everything connected, right?
That's right. That's right.
Yeah, it's pretty incredible. Is there anything that we haven't covered? What else can you tell us about Fluidampr? Again, I led this by saying, you guys are a very well-respected company, an industry leader. We all know your name. You talked about a lot of the different varieties and customizations and all of that. Is there anything that we're missing here, Brian?
I just really like to recap maybe what we've gone over, and I say I think it hopefully opened up a lot of doors and eyes to again, Fluidampr. You've heard us. We've been in the industry since '85 in all the parts catalogs, well known as a catalog item. But the purpose coming on today is like, hey, we've been doing OEM production at the automotive level and marine and defense for the last 10 years. And to open up the doors and say, hey, this is what we can really truly do and where the future can take us. So if you're working on a project, and a little sales pitch here, if you're working on a project or thinking of that, call us up. We'd love to work with you, from the ground up. We can design it, we can manufacture it, and it just really starts to getting those conversations going. So again, just to give the contact information, Fluidampr is 716-592-1000, fluidampr.com. Through those connections, they say we can get you in touch with the engineers that handle both Fluidampr and Vibratech, bring all the knowledge to the table. Again, we talked about new designs where we can tackle high RPM. We can do 2 inertia rings inside there. We can split the chamber. We can do an oil bath on the damper and cool it that way. So many possibilities. It's just getting the conversation started.
Yeah, I like that. Is there ever any concern, especially with the way the technology works and all of that, about timing marks moving?
Well, on the OE dampers, where you have that rubber bond and the timing marks are on that outer ring, well, if that rubber breaks down, you lose the elasticity of it. You lose the diameter of it. And it will crack and it will slip, and you can watch those timing marks sling past further than what they should. Beauty with Fluidampr, again, that outer housing is a sealed housing. It's not going anywhere. All the work's being done internally to it. We laser engrave all the timing marks on it. They're not going to slip on you. You get a nice clean read on it.
Mm-hmm. I like that. And the other thing, I think this is sort of a big theme, damping and fluid damping and some of the technologies you have. This is something that does continue to evolve. I mean, this is kind of the thrust of, hey, here are some of the new things we're coming out with, some of the new ways we're doing things, and a lot of the things that we've learned over time in the business.
That's the beauty of it. You take a product, it's been around since '85. You think, how can you keep improving on it? But we're always tested and always challenged by what the motorsports community is doing, especially on those higher levels. We love a challenge. And you see over the last 10 years with all these designs and changes, we're rising to it. We're adapting, we're changing our designs. We're exceeding expectations.
Mm-hmm. Yeah. And again, just such a great long company. It's fascinating to see the internals, the cutaways, and different things you show us in the slides. And truthfully, I don't even know that I realized that when you start talking about tolerances and the amount of silicone and all of that, just how tight everything is inside of there, but also how well it works, and some of the other solutions that you've talked about, being able to use different metals and, kind of solve problems depending on what some people might need, whether it be weight, whether it be some durability or different things like that. It's a lot more detailed than I think what people would think from just looking at it on the outside.
It is, and it's a truly fascinating topic, and very important to the durability of the car, or any type of, again, if you're working in marine performance as well too. All this applies to marine or defense, or I say motorsports. We work in so many industries, and it's one of those. It's one of those parts where it's just tucked down low on the motor. You kind of overthink it from time to time, but it's so vital and so important that, please don't overlook it. Think about that. Think about it in terms of durability, and it's the job of the damper to provide that.
Yeah, I always talk about how, like, we want everything. We want more power, we want durability, we all want it cheap. You don't always get all of those, but the first thing we always go for is the more power. But then, what are you compromising? What are you sacrificing if you don't? I'll say manage the power. Maybe that's the best way to do it, by dampening the vibrations, because as you mentioned, it's so crucial to the engine internals, and all of that, when those, pistons and all of that are firing, just, with the violence that they do essentially in that controlled environment.
Absolutely. More power, more vibration, bigger need for a damper.
Yeah. Brian, this has been very enlightening, and thank you for sharing the technology and the great things that Fluidampr has. And again, for those watching here in the United States, you guys are right here and making things. And to your point earlier, you could even 3D print some things and just make sure everything works and everything fits before actually manufacturing.
Fantastic. Well, thank you, Brad, for having me on. And again, feel free to reach out anytime. Francine and Judy, thank you again.
Oh, my pleasure. Thank you so much, Brian. What a great presentation. Great company, and as a matter of fact, if you want more information about Fluidampr, please visit EPARTRADE.com. We push their damper back on the homepage. This webinar has been recorded. It will be distributed through our newsletter, or social media channel, or YouTube channel as well. Next webinar will be on transmission with SADEV. So again, for more information and update, please visit EPARTRADE.com. Thank you very much, and goodbye.
Hey, we want to thank you for watching. Now, be sure to like, subscribe, and click on the bell so you're always up to date with the latest racing technology, industry insights, and exclusive content from EPARTRADE. In racing, every second counts. This is EPARTRADE, the premier business-to-business platform for the performance and racing industry. We connect buyers and suppliers 24/7 worldwide. Racing never stops, neither do we. Discover cutting-edge products and services from around the globe, gaining insights from our live platform, daily newsletters, weekly webinar series, and our highly anticipated annual Race Industry Week. EPARTRADE.com. The racing industry, every minute, every day.
ARP, the ultimate fasteners for whatever you build. To get the best performance, always follow ARP's installation instructions included with the product. For the latest torque specs, go to ARPinstructions.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series. Where can we take your business? Fifth Third Bank.
Where will you find Farea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Farea Racing Components. Stand with us or race against us.
When it comes to pushing the limits of performance, the pros know there's no room for compromise. At Crowder Cams, we don't just engineer camshafts and valve train components, we redefine what power means. Since 1955, Crowder Cams has been the name trusted by racers, engine builders, and gearheads around the globe. Whether you're building a street machine, a dragster, or a track car, Crowder Cams provides the muscle you need to dominate. And with Crowder, victory is within your reach.
At SeaTech, we're on a mission to lead the storage industry through innovative custom-built solutions that meet every challenge head-on. Designed for versatility, whether in a commercial setting or at home, we create high-quality, durable products that stand the test of time. SeaTech, engineering and innovation.